Why China is turning cargo ships into drone carriers. Advantages versus limits. It began with a ship that looked too ordinary to matter. In late 2025, images surfaced from Shanghai showing a modest commercial cargo ship quietly moored along the Huangpu River near the former Hudong-Zhonghua shipyard. At first glance, it appeared indistinguishable from thousands of other freighters supporting China's massive trade network, but closer inspection revealed something deeply unusual. The deck was stacked with shipping containers that were clearly not carrying civilian cargo. These containers mounted naval radar systems, close-in weapon defenses, electronic decoy launchers, and containerized vertical launch missile systems. What the world was seeing was a commercial vessel rapidly converted into an improvised warship. What made this discovery unsettling was not secrecy, but deliberate visibility. China was not attempting to hide the vessel or mask its new capabilities. The ship sat openly in public view, photographed repeatedly and discussed online by analysts and observers. This suggested intent rather than accident. Beijing appeared comfortable allowing the world to draw conclusions about how easily commercial ships could be transformed into military platforms. The message was clear: industrial scale and modular design could turn civilian infrastructure into wartime assets with alarming speed. That configuration alone raised serious questions about China's naval strategy. Using commercial hulls as missile platforms highlighted a willingness to blur the line between civilian and military shipping. It demonstrated how China could leverage its enormous merchant fleet as a latent naval reserve. Yet just as analysts were digesting this development, the story took an even more surprising turn in early January 2026. The same ship reappeared in a dramatically altered form, signaling that this experiment was far from finished. The missile-laden deck had been stripped down and replaced with something unexpected. Large portions of the containerized missile array were removed, and in their place sat a modular electromagnetic catapult system. This catapult was assembled from multiple truck-based segments, each locking into the next to form a continuous launch track. On the Zhongda 79 freighter, 4 truck units formed the full length of the catapult, which was installed directly onto the ship's freight deck with minimal structural modification. The size of the catapult immediately revealed its intended role. Measuring just under 50 meters, roughly the length of 4 shipping containers, the system was far shorter than the EML's catapult used aboard the USS Gerald R. Ford, which exceeds 90 meters. Unlike the Ford system, designed to launch full-sized manned fighter jets such as the FA-18 Super Hornet, this compact catapult was clearly intended for much lighter aircraft. Its scale pointed directly toward unmanned combat aerial vehicles. The drones displayed on the deck reinforced that conclusion. Visible on the ship were what appeared to be models of Chinese collaborative combat aircraft, often referred to as loyal wingman drones. These were almost certainly mock-ups rather than flight-ready prototypes, but their purpose was obvious. These drones are designed to operate alongside manned fighters, extending sensor coverage, carrying weapons, and absorbing risk while remaining under the control of human pilots. Their stealth-focused design, including canted tail fins, suggested an emphasis on survivability in contested airspace. Even more telling were the details visible beneath the airframes. Earlier images of these drones before their appearance on the ship showed clear signs of navalization. Each drone featured a catapult launch bar attached to its nose landing gear, designed to lock into the electromagnetic launcher. This confirmed that the system was purpose-built for catapult operations, rather than adapted as an afterthought. The specific drone model mattered less than the broader implication. This catapult was designed to launch drones, not fighter jets. In just days, the ship's mission had fundamentally changed. What was once a floating missile battery had become a makeshift drone carrier. This transformation did not turn the vessel into a true aircraft carrier, or was that ever the intent. Instead, it demonstrated how far China is willing to push modularity and improvisation in naval warfare. The speed of the conversion was the real story, not the elegance of the result. This ship did not undergo a lengthy naval refit or dry dock overhaul. Modules were removed, rearranged, and replaced directly on the open deck. The electromagnetic catapult was bolted into place, aligned, and presumably connected to a power source. Radar systems, communications equipment, and defensive weapons were retained, while other modules were sacrificed to make room. Of the original 60 vertical launch missile cells, only 24 remained after the modification. This approach sacrifices efficiency in exchange for speed and scale. From a naval architecture standpoint, the layout is far from optimal, but it is fast, flexible, and industrially scalable. The ship now functions less like a traditional warship and more like a floating chassis, capable of accepting different mission packages as required. Shipping containers are standardized, stackable, and compatible with existing logistics systems, making them ideal for rapid reconfiguration. This is where the true advantage of the concept becomes clear. China can pre-build mission modules in peacetime and stockpile them ashore. In a crisis or conflict, those modules can be rapidly loaded onto commercial hulls. 1 week, a ship can function as an arsenal platform. The next, it can operate as a drone launch vessel. Western navies have discussed such modularity for decades, but few have implemented it effectively. Yet the limitations of this drone carrier are just as important as its strengths. There is no visible landing or recovery system on the ship, no flight deck, no arresting gear, no nets, and no obvious method for bringing drones back on board. This strongly suggests a launch-only role. In practice, that means drones must land elsewhere or be treated as expendable assets. In regional conflicts, that limitation may be acceptable. Operating close to China's coastline, island bases, or friendly airfields, drones could easily recover ashore. In some missions, one-way strike or decoy drones may be entirely expendable. A launch-only platform could serve as a forward node, deploying reconnaissance, strike, or deception drones without risking high-value carriers. The ship itself does not need to fight on the front line. It can operate under the protection of friendly fighters, surface combatants, and land-based missile defenses. Any remaining missile capacity can be used for long-range strikes rather than direct engagement. In distant waters, its lack of recovery capability would sharply limit usefulness, but near home waters, it could still play a meaningful role. The catapult's origins reveal an even deeper strategic choice. The electromagnetic launcher appears derived from a road-mobile system previously seen on land. This suggests China is pursuing a common launch architecture usable from trucks, barges, and ships alike. Such standardization reduces development costs, simplifies training, and reinforces a core idea: the platform matters less than the payload and the network controlling it. The timing and location of this experiment were anything but accidental. The ship sat near a yard associated with advanced naval projects, including the Type 076 amphibious assault ship, which also features an electromagnetic catapult for drone operations. The visibility, proximity, and sequencing strongly suggest intentional signaling. Beijing appears comfortable letting the world see how quickly it can repurpose civilian vessels for military roles. Even small corrections reinforce the seriousness of this effort. Earlier assessments underestimated the missile load of the original configuration, which carried 60 vertical launch cells, not 48. While this correction does not change the broader analysis, it highlights the scale of firepower that can be placed on a commercial hull with minimal modification. In the end, the message is consistent across every configuration. China is openly experimenting with ways to turn commercial shipping into rapidly adaptable military platforms. These ships are not replacements for destroyers or aircraft carriers. They are supplements, tools designed to add mass, flexibility, and resilience in a conflict defined by attrition and industrial capacity. And in future wars, scale may matter more than perfection. By trading elegance for speed and refinement for adaptability, China is betting that modularity and volume will outweigh traditional naval design advantages. Whether every element of this concept is fully mature is almost irrelevant. What matters is the direction, and it is one the world cannot afford to ignore. If you want deep analysis like this that cuts through the noise and explains modern warfare clearly, make sure you subscribe to Defense Strike Matrix now.